this episode how to find the domain of logarithmic functions. Coming up, back into action. Hey guys, today I will show how to find the domain of logarithmic functions. And I will get into basic kinds, and for more harder types you could jump into my second episode. And by the way, what is the domain of a function? It's basically a set of all possible values of x that can be plugged into your function, or where your function has an algebraic meaning or defined. As a good rule of thumb, for log functions, all you need to keep in mind, and there are a couple of things that going around here. Generally speaking, your log function has two parts, namely the argument, which is denoted by a of x in this case. It can be any expression in terms of x, or it could be just a single number. And also your log function has a base, which is indicated by b of x. So it could be any expression in terms of x, or it could be just an actual single number. Anyway, there are restrictions for that expressions. First of all, your a of x, your argument, has to be greater than 0. Your logarithmic function is not defined for negative values of x. So your entire argument, or your inside of your log, has to be greater than 0. That's the first restriction. And the second one comes from the base, from that b of x that happens to be a base of your log function. First of all, your base, it's always greater than 0. It's also a positive expression, or a number if it comes to this. And the second restriction, your base cannot be equal to 1. So keep these things in mind while you find the domain of log. And generally speaking, if you need to find a domain of other functions, so it depends, generally speaking, of a function that you are given. And if you need help with this, of how to find the domain for different types of algebraic functions, like a fractions, a root, a fractions over an algebraic expression over a root, you could jump into my other videos where I explained how to find the domain of other types of functions. Anyway, let's get back to this. Suppose you are given the first one. So since you have an argument of your function, and it happens to be an expression in terms of x, so namely it's 3x plus 1, it's the argument of your function. All you do is just take this argument and you set it greater than 0. So your argument, so you could just look up at this kind of mnemonic hint, your argument has to be greater than 0, it has to be positive. So you would simply pull it out, this 3x plus 1, you pull it out from your function, y equals this log, and set it greater than 0. So since your base happens to be just a number, is just 2, a single number, and 2 is a positive number, so you could simply ignore these two restrictions, so you don't have to deal with the rest. So, and all you do is just solve this simple basic linear inequalities. So it comes down to just solving linear inequalities, and if you need help with that, you could jump into my linear inequality video for that explanation. So you would simply move this one to the right side by subtracting one from both sides of your inequality, and you will end up with getting just 3x greater than -1. And the next step, you just divide both sides by 3, and it becomes that your x is greater than -1/3. So this is basically the answer. This is the domain. So it's the set of all real x's, the real values of x that satisfy these inequalities. So your x's have to be greater than -1/3. You could write this answer using an interval notation if you like. So you would simply write using the interval notation. It's from -1/3 all the way up to positive infinity, and this is your d, which stands for the domain of that function. So either this way or that way for writing your domain for that log function is perfectly fine. Moving on. Say you have been given something like this. This is a little bit different from what we did before, and obviously I'm giving that another case to you on purpose. So your variable x is located in the base of your log. So x, and basically that's expression 3x, happens to be as a base. And since your argument, your inside of your log is just a number, namely a half, and it's obviously it's a greater than 0, it's a positive number, so the first restriction has to be simply ignored at this point. So we don't need to set it greater than 0. Moving on for the next two restrictions for your domain. So all you do is just you grab this base, namely 3x, you set it greater than 0, that's first restriction, and you pull down the second restriction. Your base 3x has to be not equal to 1. And notice you pull down 3x, not x at this point. So whatever you are given as a base, you grab it entirely, you take it entirely. So, and you set it first of all greater than 0 and is not equal to 1. So, and all you do, you solve these two. Basically, it's inequality and in another kind of inequality, because it's not equal, it's unequal, but you solve them anyway. You solve them simultaneously at one go. So for the first one, you simply get that your x, you will end up getting your x is greater than 0, since if 3x greater than 0, then obviously x is greater than 0. And for the second one, all you do is just simply divide by 3 both sides. You want to get this x alone, and 3 goes away, disappeared. So you will be left with x is not equal to 1/3. And again, you could write your answer as a phrase like all x's that greater than 0 except 1/3, and 1/3 has to be excluded. So excluding this 1/3, so your domain D is all positive. So you could write all x's that greater than 0, or in other words, all positive values, x values, or values for x, except a third. Or you could use the interval notation if you like, and you could place it on a number line. So this is your 0 and this is your a third value, and you go that direction. All positive values of x, excluding except this a third. So if you need to write it using the interval notation, it's the same thing as, so we go from 0 till a third. We need to join it, combine with a third, not including a third, notice, in both cases, all the way up to positive infinity. And that's your final answer for that domain, for that problem. Alright, again, it was a basic kinds of problems where your variable appears as an argument and as a base of your log. And if you need help with more harder kinds, you could keep watching my second episode on how to find the domain of logarithmic functions. Well, I hope it helps you. Thanks for watching and training your brain. I know everyone hates maths, but if you like my video, please smash like, share with your friends, leave the comment down below, and be sure to subscribe so you will not miss out my new